Hi, all. I want to take a brief moment to thank you all personally for supporting this podcast on YouTube and on all major podcast platforms, including Google Podcasts and Spotify. The podcast mainly features interesting people in robotics, artificial intelligence, and entrepreneurship. If you believe that the information that I'm providing might be of benefit to you or to someone you know, it would be really great if you could hit the subscribe button and press the notification icon so that you can get notified on time whenever the next part is out. It would literally take you a second or two to subscribe to the podcast, but it would really mean a lot to me because I can grow the podcast to a level where I can reach more people, invite ever more interesting guests, and have a more meaningful impact. So let's begin now. Now we will move on to electives. So one of the things that is really important to understand is how to choose an elective subject.
Yeah.
So as Vamsi explained very elaboratively and very clearly that once you go through the first semester with all these subjects, you get understanding, okay, that I like CSME, I like the computer science, side of robotics, or maybe you like control more, maybe you like the mechanical side of things. So you get some idea, and then you study more subjects like computer vision, one sensor systems, and MBD in the next one. Then you get more clarity. Okay, computer vision, which is further, has machine learning part of it as well, and other computer vision techniques as well. And maybe you decide the computer vision. Let's take a hypothetical case that you decide computer vision 1, you want to go into computer vision for robotics applications.
Yep.
So then how do you choose the elective? So the first one is computer vision 2 here. So obviously if you think that you want to go into this field, then this thing would be visible on your transcript that you have taken this thing, and employers would see this, and so this would show your interest in it. And obviously if you would be interested in this subject, you would take this one as an elective. Computer vision 2, as we know, was built up on computer vision 1.
Yeah. And
applied numerical optimization I didn't take. So Vamsi will explain.
So applied numerical optimization is one branch of engineering where you optimize to find goal objective with some constraints. It's pretty much needed for robotics in my experience, especially from my heavy work and part-time work, where we used optimization techniques to simulate robots and to optimize mechanisms, or maybe you can optimize any sort of objective with some constraints. So optimization, numerical optimization is more or less dealing with how you optimize a particular parameter, considering an objective function, and it's given under given constraints. So for example, if you would want to optimize the trajectory of robot, then the techniques which we study in advanced numerical optimization, not advanced, applied numerical optimization. So, okay, leave it.
Applied numerical optimization.
So it's actually not advanced, it's applied numerical optimization, where for example in robotics perspective, if you would want to optimize the trajectory, and then if you want to optimize any certain parameter, like if you want to optimize the force constraints, if you want to optimize the application of forces or torques, or maybe optimize the trajectory, you would apply the techniques which you studied in applied numerical optimization.
So who should take this course? Like for example,
if you are it can be applied in any kind of robotic streams. Like for example, if you want to optimize sensor values, or if you want to optimize the perception, you can apply these techniques. It's a general branch of engineering. It's not related to mechanical, it's not related to electrical or something like that. Even you can even apply optimization to schedule flights. Is one of the example, in a best way of scheduling, like all the traffic lights are based upon optimization techniques. So anyone who would want to improvise the robotic systems, who would want to develop the robotic systems, can be interested to take the applied numerical optimization.
Okay, so generally it can also be, it is some of the portions are also in machine learning and other subjects,
Yeah.
right, from this subject.
Yeah, like a more or less similar thing. Like you will see some topics which are related to CSME. You will see some topics which are related to machine learning.
Yeah.
But more or less, the subject deals with optimizing a variable or optimizing a parameter, physical quantity, could be anything,
Exactly.
with one objective function under some constraints. Yeah.
Okay, so and how was the exam for this, quickly if you can tell?
The exam is like 2 parts in this subject. Like 10% you will be graded for your coursework or exercises, you can say. So the exercises are in MATLAB. So when you successfully complete the exercises, and when you submit the exercises to the particular department or people who are organizing the course, and they will grade your marks, and the 10% of marks will come from the exercises, and the rest of the 90% you will get it from oral exam.
Okay.
And so you will be asked some questions, and based upon your answers you will be graded the marks.
And how was the difficulty level?
Difficulty is medium for me. So
Okay.
of course it varies from
Person to
person.
Yeah. Exactly. So the next one is numerical methods, which is of 7 credits, and that's why everyone takes it. But numerical methods is, as the name suggests, it's totally numerical based,
Yeah.
and the exams are really simple for this particular course, and it is easy to get good grades.
It's nothing but mathematics.
Yeah.
It's more or less the total title, the complete title of the subject is Numerical Methods in Mechanical Engineering. So here you will study in lectures. Of course, you will study a lot. It's a very vast subject. A professor explains in detail how each and every numerical method would be applied in mechanical engineering.
Even derivations and everything is covered in the
like,
lectures.
For example, consider a beam, consider structure, consider a mechanism, consider the strength of materials, how we can apply numerical methods. Lectures would go very deep, but no need to worry about when coming to exams. Exams are not so relied on like solving real engineering problems, but exams are more or less like
again exercise based,
more or less problem solving of particular techniques, which you will study in numerical methods.
Exactly.
So in mechatronics and control techniques, you will study about basic mechatronic systems, and you will again study about robotics as well as one chapter. For already, if a guy is already having mechatronics background, it's not so tough. For me, it was not so hard.
You already studied the things before, right?
But I would suggest to take up this course, because this course is really this course is very interesting for me, even though I studied mechatronics in bachelor's, because this course was structured based upon industry, and you will study PLC programming. You will study, if at all you are not from electronics background, I would really suggest to consider this subject, because you will have a basic understanding of electronics, basic understanding of control systems, all basic understanding, also the PLC programming, also maybe some gripper systems, how the mechatronic system is organized. More or less, robotic system is nothing but a mechatronic system. So
but if somebody who is want to go into computer vision, for that person probably it's not very relevant, but it's like foundational in a way.
Yeah. So if you are intended to go only with respect to programming way, maybe you can skip this subject.
Yeah. But if you are more interested in exploring more about control
engineering
and mechatronics overall,
then it would be helpful for you.
Okay.
And I will definitely suggest for a guy who is from mechanical background or who is only electrical background, I would suggest to go with consider this subject. Exam was actually from our batch. Exam structure was changed. Of course, exam is totally dependent upon exercise. Also, there are some parts of theoretical questions, but if you are able to solve previous question papers, and if you are able to solve exercises, you're thorough with exams as well.
So focusing on exercises mostly.
Focusing on
advanced control.
No, I've not taken it.
Okay, so this is added by mistake. None of us have taken advanced control, but advanced control is really advanced.
Yeah.
It's not very easy. I have not taken it, and he has also not taken it, so we cannot tell more details about that. So, intro to AI. So, this one is also, I think, pretty preliminary,
Yeah.
because this one is basically the traditional AI algorithms, breadth first search, depth first search, and all these things, and it is mostly exercise based. So, moving on to strategic technology management. So, this is the subject that Vamsi was talking about
Yeah.
in the beginning of the talk. The
So,
only managerial
only managerial
subject.
subject which we have is strategic technology
But
management. The strategic technology management is a managerial subject where the exam is structured in two parts. 50% for your presentation given for a given topic to you,
Mhm.
and you will be forming a team and you will present the topic in with team, and the rest 50% is based upon your written exam. So
Yeah.
written exam is completely theoretical. It's more or less like memorizing all the topics, and also application based, like whatever you studied in strategic technology management, you will be asked some questions which are more how you apply these such topics. Yeah.
Okay. So production metrology, I think none of us
none of us
took,
took
so we cannot talk about it. And advanced machine learning is, as the name suggests, it's advanced.
It's-
Personally, I thought it was really hard.
Yeah, it's true.
It is also Professor Laibe's course, so it was well structured and everything. But I think the algorithms were more advanced, and so
advanced.
you had to spend more time, and it was
To
a bit
understand.
hard to score as well for me at least.
Yeah.
And yeah, I mean it's the same as machine learning, so I don't think we should talk more about
It's more
that.
the structure, course structure, exam structure
Yeah.
is more or less like machine learning, and of course it's advanced version of machine learning. So you will study more probability
Exactly.
here.
So more math,
Yeah.
that's it. And AIDAE, I think this one I particularly like about the structure, but it's a bit more basic version of machine learning
And AI algorithm.
and AI and artificial intelligence stuff that you probably study here, but more basic. But what I really enjoyed in this course was the exercises,
Yeah.
because here the theory is very less, and the exercises are such that you apply everything that you learn, and the exercises are really well suited for beginners. So the exercises were good, but the exam is more theoretical.
Yeah.
Talk about the exam.
So the subject is more or less like you will study theoretical based algorithms, math and all. You will study in machine learning, advanced machine learning, and maybe in CSME. But the practical implementation or programmatic implementation you will study in AIDAE, which is nothing but artificial intelligence and data analysis for engineers.
Here they actually encourage you to participate in programming activities. Of course, exam is still theoretical.
But in exam, some part were programming.
Yeah,
It's
some
not
part
like
was programming
completely
based as well.
theoretical, but there were programming part as well.
But you write the program on the sheet of paper.
You will not have any grades for exercises or programming part, but all exercises were program related. You will learn how to program. If you are a beginner for programming, I would suggest you to consider this elective, because you will
also in the beginning of the course you had an introductory Python course as well in the first or second lecture. Yeah.
So you will learn about Python, libraries of Python, how to use Python. This subject is more or less how to use or how to implement machine learning algorithms, but it's not, you won't see much of math here.
Exactly, more of implementation
part.
So this was good. So couple this with machine learning subjects, theory plus practical, and you are an expert.
Yeah.
Anyway, so now moving on to factory planning.
No, I have not taken factory planning.
Okay, so again, but this was also a theoretical subject, and factory planning and industrial logistics. I think Vamsi also explained briefly in the beginning that they are more application oriented subjects. Yeah. So now this is something that I have kept for last year. I won't even say the name of the subject. You will explain it.
Actually, this subject, advanced electrical drives, was one of the toughest subjects in the entire course, which I personally find it tough as well. This course.
But you still gave the exam.
Yeah.
One of the very few. How many students gave the exam?
I think I was the only one who gave this subject.
In our
batch. Yeah.
Okay.
The subject is pretty hard actually, but for if you have an electrical background, you might not find it very hard. But me as a mechatronics background, for a mechatronics guy or for a mechanical guy, the concepts would be they have been to very deep understanding of electrical drives. What basically this subject is about, like you will study about different kinds of motors actually, like synchronous motor, asynchronous motors, DC motors, and also switch torque reluctance motor. So it's not just about the construction part of the robots. It's not just about construction part of drives. These motors are more how they are controlled as well. It's more math involved, like controlling part of these particular motors. First, the structure is like in one chapter it will be like mathematical modeling of a motor, and the consequent chapter is how to control this motor for the mathematical model you have already modeled in the previous chapter. So it's well structured, and it is very much useful if you are planning to go in the direction of control part of robotics.
Even in electrical vehicles, that is also one of the fields that is important for the future as well. But also in this robot, there are electrical drives. So the electrical
motor as a robotics engineer, you won't be developing electrical drives, or you won't be developing motors, but if you have a quite well understanding of this particular subject, it will help you development of robots, because as electrical drives or motors are one major part which actuates the robot, which actuates the mechanical system, which is a bridge between a software program and mechanical response. So it is quite helpful for you to understand, or if you are interested to go in that direction.
So I think if someone is more control oriented, then control engineering oriented, then he should take this course. And also this course is like lectured by one of the really great professors, Professor Donker, who is very well recognized all over Germany for his work in electrical vehicles, electrical drives. So this is a very good course, but very difficult to score as well.
Score in the exams.
So as you can, as Vamsi told, he was the only person who gave the exam in our course. So
it's nothing great from my end. Like the thing is, like I didn't want to study another subject. Once I studied, so I gave.
But I mean, most of the students were like really scared that it would be really difficult to give exam for this subject. So 10 points to Vamsi for that. So now there are 3 subjects that I have mentioned in red. So there's something called curriculum change as well, where you can add new subjects to your list of electives and exchange it from a previous. So there's a formal process, and you would have to talk to the faculty in charge and people who are responsible for the curriculum. So you would have to sign a form for curriculum change and get it get it approved by by professor. So once you decide that you would have to take a course that you would want to add to your electives, then you would have to do a formal procedure where you would have to fill a form of curriculum change, write the name of the new curriculum, maybe also write the name of the old elective that you would want to replace, and get it attested by a professor at IGMR. And once it gets approved, then it works as a normal elective and you get credits for it. But this thing you have to do before you give your exam, not after you have given and you decide, okay, I got a good score and I would want to include it. No, you have to do it before. And also one important thing is not every subject gets approved, so you have to, that's why you have to ask and get approval of the subject from the faculty, because some subjects might not be relevant. So one of the subjects that three of the subjects that I took and I got added to my curriculum were autonomous driving, self-driving lab, which is of just 2 credits, but I highly recommend it because you actually implement it in programming, all the self-driving from perception to prediction to control all the aspects of autonomous driving. You get a really good understanding of this subject. So autonomous driving is a theoretical subject and self-driving lab is where you implement it. So that's why I took a combination of these courses. I think autonomous driving was 5 credits and self-driving lab was 2 credits. And also I would really recommend self-driving lab now, even because when I took it, it was on an autonomous driving framework called ADTF, but now I think it is being taught in ROS. So that's even good. You would add ROS to your skills, which is highly important for robotics. And other subject that I took was RMMI 1, Robotics and Man-Machine Interaction 1. You can also add Robotics and Man-Machine Interaction 2, which would cover some algorithms from RCAD, and RMMI 1 was more similar to Robotic Systems. So yeah, you can choose any other subject, and if you can get it approved, then it works like a normal elective.
So if at all you find some other subject which is more interesting, but if at all you don't want to include in your curriculum yet, you can get it in your transcripts. Like for example,
Yes.
I have taken one additional subject for which the grades wouldn't be considered for your total grading. If at all you find any other subject as interesting, you can take that course freely, and you can just give exam, and it can be included into your transcript. Need not to be that it will be counted for grades.
Yes.
But if at all it should be counted for grades, as Chandradeep said, you will have to get it approved from your department, as stating that this subject is more or less relevant to robotic systems.
Exactly. So this is another good point that Vamsi mentioned, that you can take an additional subject. Maybe you don't want the credits for this, you want the credits for the existing subjects, but if it is added to your mark sheet, this additional subject, maybe you want to go into autonomous driving, and if you take autonomous driving and it is being displayed in your transcript of records, then the employer would see that okay, you went a step further and took a subject of your interest,
Extra subjects.
even though you might not get credits for it, but the marks and the subject would be displayed. So that's
displayed in
also
the transcript, even though if it is not counted for your complete marks.
Exactly.
But need not to be that every subject can be approved for your to include it into your curriculum. Then in that case, you can take it as an additional subject.
And Vamsi, you also took an additional subject.
Yeah, I've taken one additional subject, which is like Introduction to Research. It's more or less like how to do research, how to write research papers and all, like more or less like an additional subject. It's nothing technical.
So because Vamsi is more research driven, so he took a subject of his interest, and likewise you can take any subject that that interests you.
Any subject which is within RWTH Aachen University. But provided the professor who is hosting the subject, or professor or the teaching assistant who is conducting the course should approve your place in the classroom.
Okay.
So in some subjects, if there is a free slots, you will be given an opportunity to sit in the classroom. You will get the documents as well. So you can give an exam as well.
So you can take any subject regardless of whether it is related to robotics or not and add it to your curriculum. But if you want credits, you have to get it approved, and not every subject will get approved.
Will be approved. Only the subjects which are
relevant to
robotic
robotics
systems. And
exactly.
even in the additional subjects, if you register in the online portal, the professor or the teaching assistant should approve your place. So if it is more in engineering, you will more or less you will get an approval. But if it is some other courses like psychology or physics or any other thing, it depends upon the professor whether he should give you an opportunity to study that course or not.
Okay. Yeah, that's a very useful information. Yeah. So now let's talk about a very controversial topic, Vamsi. Are you ready for it?
Sure.
So the controversial topic is that all these subjects that we study, they are theoretical more or less.
Yeah.
And it is arguable that we could have more, programming based courses, for example, like the one I took. So what is your take? What is your critical evaluation of the curriculum, and how relevant do you think it is from an industry point of view?
For actually, as it is said in Germany, you will have two kinds of universities. One is a technical university,
So RWTH is a research university.
or
It's
you can say technical university,
a technical university.
or university. So the other kind of universities are FH universities, which is nothing but Fachhochschule. These universities are more practical oriented or industry oriented, which are not research oriented. So Germany believes that theoretical knowledge is a strong point for research.
Exactly.
So you will more or less you will gain practical experiences via part-time jobs like Hiwis, Studentische Hilfskraft or Wissenschaftliche Hilfskraft. And you, even though you don't need to bother about whether I don't have more labs, it's more or less theoretical. You don't need to bother about it because you more or less you will gain practical experience either by Hiwis, part-time jobs, or through internships.
Yes.
Because you have a mandatory internship in the curriculum and through master thesis as well. So if you are research oriented, you should not worry about there are very less labs or something like that. But yes, as said, Germany believes in this concept. Like in Germany, the education system is break down into two types of universities: technical universities and universities which are concentrated more on theoretical sense and research oriented sense. And in FH universities are called as Fachhochschule. In English, it is translated as University of Applied Sciences, where you will in those universities PhDs are not offered. So you will, once you if you are more into like a practical oriented, not research oriented, if you are more into industry oriented, job oriented, then it's more relevant to opt FH universities. And nothing is more, nothing is less.
Yeah, exactly. So
like
it depends on your
personal
preference as well.
interest.
So if you are very sure that you want to go into an industry, you want to do a job in the industry, then FH is very good option because you get practical experience. But if you are doubtful that I'm not sure if I'll work on in industry or in research, then this is very good because as we mentioned, you get really in-depth understanding of all the courses, and in research, while doing a PhD, you have to formulate your own algorithms, for example, in machine learning, or formulate your own laws, and you cannot do this when you are just learning to use a tool, a black box or a package you implemented directly. So in that case, these subjects would be very important.
But in my view, it's totally fine because even though you are studying in technical universities, you will gain practical experience either by Hiwi, by internships, by master thesis. So nevertheless, you will have a practical experience by the end of your master studies.
Exactly, because internship is mandatory as well.
Yes.
So after the third sem, we have the fourth sem where internship and master's thesis need to be done.
Yeah.
And so let's talk about, you talk about practical experience.
Yeah.
Let's talk about how to find your first student job.
Yeah. In my experience, it is, you can't say it is very tough or very easy as well. I got my first student job in the second semester, or more or less in the end of first semester.
Okay.
During my exams. So especially in RWTH, you have a separate job portal where you can find all the listings of student jobs, which is called as Hiwis or student job Angebote, like student job offers. So you can find out a complete list of jobs, And
all the lists of jobs available would be
in
there.
the whole university. So each and every chair or each and every faculty or institute post their jobs in this particular job portal. You can click on the particular job application and you can send contact person who posted the job. So more or less these people who are pursuing PhDs or maybe postdoctorates post these jobs so that you will assist in their research as in part-time while you are studying, so which will really help you for your further career growth. So it is highly recommended that every student at least pursue at least one heavy job.
Yeah. So the practical you gain a lot of knowledge and practical experience from a student job or a heavy.
Yeah.
So, and as Vamsi rightly mentioned, there's an official portal, and you can also visit the official websites of different institutes and check for the openings. It's there on every website.
There are two places where you can find student jobs. One is like job portal, which is centralized job portal for the all institutes, and the other place is like visiting each and every page of individual faculties or individual chairs. So every chair is having their own website again. So
and there would be a student job openings portal section where you can find out
the jobs. So that's how the same way I found my jobs. In the first job I found it from institutional website. Second heavy job I found it through centralized job portal.
Yeah.
So once you open the advertisement or like job posting, you can contact the person directly via mail. So they will schedule an interview, you will attend an interview and you will be notified in a week.
Yeah, sometimes they also give a small programming test.
Yeah.
There are different ways of evaluating, right? So and also the one thing I would like to add is that you can also get a working student position at an industry as well, because on the websites of the companies you have a student job openings position as well. So you can apply there as well.
You have industry work student experience.
So for example, my working student experience was in an industry. You should apply everywhere basically. So basically you apply on the website, there is opening, and then you go through the formal procedure as Vamsi mentioned. So the same thing that goes for applying at institutes goes for applying at industries for a working student, and there are lots of working student positions both in industries as well as in institutes. So just keep applying.
Yeah.
Vamsi, so that was very elaborate the way you explained how to get a student job.
Yeah.
And another thing that is asked very often is that it is not possible to complete a course at RWTH Aachen University in just 2 years. So how do we structure our courses? In each semester, how many subjects should one take? And is it possible to do it in 2 years? And if not, why? What are the reasons?
Coming to the discussion on subject loads on a student. So of course it varies from student to student. In my experiences, I took on an average 5 subjects per semester according to the curriculum. Of course, you can skip one subject in one semester and take it in the other semester. In the similar way, like 2 or 3 subjects, I did it in a later part of time. So theoretically, it is possible to complete within 2 years, but theoretically, but practically, it is it's very difficult to complete the whole course within 2 years of time. You will have to do internship as well as master thesis. According to curriculum, theoretically it was given 3 months for internship and 3 months for master thesis, but it's quite impossible to complete within the given time span, because the practical reasons are like in a company it's very often that some companies offer you 3 months of internships period, because
it's not very productive for companies. They prefer that you do an internship with them for 6 months.
6 months. It's not very likely that a company will offer you only for 3 months, and in that sense, it is of course it's very difficult to have an internship and master thesis get completed within 6 months. So once you complete your internship, maybe it spans like around 5 months or minimum like 5 months or 6 months. So there itself, your semester would complete.
So 2 years are over by the
By
time you finish your internship. And also depends on how quickly you find an internship. Sometimes it takes time, and so maybe there's 2 or 3 months gap there. So that's why it will go to 2.5 years, because remember, you also have your master's thesis left after
your internship. So and when you enter into a master thesis, if at all it is in an institute, there is a possibility that you can complete a master thesis in 4
months or so,
5 months. But companies wouldn't offer you a master thesis just for 3 months. Of course, even companies would offer you like for 5 months or something. You need to have some preparation prior to your master thesis, maybe for 1 month. And finding a master thesis again will take some time. If at all you're lucky, in the same company where you worked for internship, you will be given a master thesis as well. So there are more chances that you will have a master thesis in a company where you work. It will take more than 6 months to complete your internship as well as master thesis. That's the reason why usually people say it is very difficult to complete master course within 2 years. But exceptional cases were there, like some of our classmates did complete within 2 years.
So you talked about how to get a student job.
Yep.
Now let's talk about how to get an internship and what are the skills you would have to cultivate in yourself before you can get a suitable internship.
If you want to apply for an internship, it is highly recommended to apply a semester prior, because the application filters and interviews will obviously take some time. And once you have got an opportunity, or once you are offered an internship, it will take minimum a month or 2 based upon the companies to start your work. So
for the official contract
to start, or official start date of your internship. So in order not to waste your time, it is always recommended to apply a semester before 1 semester, or maybe like 3 or 4 months before when you plan to start your internship. So for robotics engineer, you have companies like ABB, KUKA, and Bosch, and companies like BMW.
You can also apply to Fraunhofer, Max Planck Institute. There are lots of companies, so you can search online.
And you apply, like it is recommended to apply like 4 or 5 months minimum before this.
6 months before is recommended.
Obviously.
And what are the skills one should have before applying for an internship? What are the skills that they look for?
As a robotics engineer, one thing they definitely look into is like your programming skills. Even if you're working with design part, programming skills are playing an important role for a robotics engineer.
Yeah, programming skills are a must in any way.
Even
if you don't choose to take a robotics related job, maybe you want to go for machine learning for the medical applications or healthcare applications, you still need to learn programming.
Even if at all it is a mechanical design, like for example optimization of mechanical parts, MATLAB programming or Adams programming are quite necessary.
Yeah, exactly. So the programming language would change probably. If you go to mechanical, then you would have to learn the softwares, right? M.Sc Adams, the ANSYS analysis softwares and stuff like that. And also MATLAB would be more important.
MATLAB plays an important role for every stream, where you definitely have to simulate either mechanical
a system in
general. So MATLAB and Simulink would help you a lot. And
even for control systems, MATLAB would be most important.
So the recommended things are like MATLAB and Python and C++ are the 3 recommended programming languages for a robotics engineer. In my personal experience from prior professional and master course, I feel like it's better to learn Python, C++ and MATLAB for a robotics engineer, which will really help you to get into internship or master thesis or maybe a job.
Overall I think you should decide which programming language you should learn, but How you decide is because I think when you take all these courses, once you would have a clear direction of where you want to take your career. Maybe you want to go into machine learning core, and then you would have to have TensorFlow and PyTorch. You would have to have experience with TensorFlow and PyTorch, and Python would be more important, right? Or if you want to go into computer vision or control or a hardware related, whenever you are dealing with hardware, C++ would be more important for robot manipulator arms. Even if you're using computer vision systems or other systems,
or if you want to control electrical drives, C++ would be helpful. So basically for a robotics engineer, in our opinion, MATLAB, Python and C++ are very much important for a successful career in robotics. But the best is to decide which direction you want to go. I think after 2 or 3 semesters you would know which direction you want to go, and then choose on mastering one of the things. But at least Python you should know. Right? But in my view, it's better to learn all the three programming Python languages. I mean, definitely. If you know Python, C++ and MATLAB, then I mean you are open to a lot of other opportunities, even if you're not clear, right? That's true. So it's always recommended, or in my personal experience, I have encountered using all the 3 languages in different experiences. So C++, Python and MATLAB are highly recommended to learn. Another thing to add is ROS. So ROS is super important because it's the framework, and then you can use Python or C++ because it supports both of them. And for robotics applications, you have to learn ROS because it is being used by industries and industries sometimes have their own frameworks as well. But if you know ROS, you know how the framework works, and the other framework would be more or less similar. So ROS is also important. ROS, Python, C++, MATLAB, and for machine learning core, you should know TensorFlow and PyTorch. Okay. Thank you very much, Vamsi, and I hope this thing was also helpful to a lot of viewers who would be getting enrolled in Robotic Systems Engineering. If not much, but maybe 1%. Hey guys, I really hope that you enjoyed this particular conversation and it helped you in some way, shape or form. If it did, make sure to hit the subscribe button and the notification icon or the bell icon so that you can get notified on time whenever the next part is out. Also, it would be really great if you could give me your feedback in the comments below. That would really help me improve. I'm uploading small clips of the long podcasts on a regular basis on platforms like LinkedIn, Facebook and Instagram. So make sure to follow me on these platforms if you're someone who cannot take out time for the long episodes. The podcasts are also available on all major podcast platforms including Spotify and Google Podcasts. So if you're someone who prefers to listen to podcasts rather than watching full-length videos, make sure to follow on your favorite podcast platform. Thank you very much and see you next time.